Welcome to the last video for Module 13. We'll be wrapping it up with radioactive dating. We have 3 vocabulary words to discuss. We have radioactive dating, carbon-14, and half-life. So radioactive samples will eventually cease to be radioactive. Each radioactive isotope has its own half-life. As an example, one of the most common ones used for dating is carbon-14. It has a half-life of 5,700 years. It would take more than 50,000 years for a sample of C14 to decay totally. As an example, and for comparison, it would take 4.5 billion years for a sample of uranium-238 to decay totally. So how do they do radioactive dating? Well, isotopes decay at a measurable rate, and they use this measurable rate to determine the age of objects. This is what is known as radioactive dating. Radioactive dating can be accurate under certain circumstances, but not all circumstances. Consequently, the process needs to be viewed with a skeptical eye. Radioactive dating does not prove evolution. Carbon-14 can't measure millions or billions of years. So when you watch something on the TV or read something that tells you that they just made a discovery and they dated it to be 2 billion years old, there is no dating process that's accurate to do that. Carbon-14 decays by beta decay with a half-life of 5,700 years. Living organisms continually exchange carbon with their surroundings, so the whole time they're alive, they're exchanging carbon. This means that living organisms have the same amount of carbon-14 as is in their environment while they're still living. When an organism dies, it ceases to exchange carbon-14. Consequently, the amount of carbon-14 begins to deteriorate or decay. Every 5,700 years, half of the carbon-14 will decay away. So that's what half-life means. Only half will be left for every 5,700 years that passes. The rate of decay can be used to measure the length of time that an organism has been dead. For this process to be accurate, the amount of carbon-14 in the organism when it died must be known. So it has to be a measurement that we knew for this to be accurate. Scientists often make assumptions as to the level of carbon-14 that was present when death occurred. And they have different methods that they've done this with, none of which are accurate though. It's always an assumption that's made that certain levels were available in the past. Because of changing carbon-14 levels, sometimes assumptions are not accurate. So even if the original assumption was true, the levels change all the time. So it may not be true. Scientists use carbon-14 level that has been established by sectioning tree rings. Tree rings can be counted to tell how old a tree is. So the carbon-14 from the tree can then be measured for each tree ring, which signifies a certain amount of years. Generally, for many trees, one ring will equal 1 year. Scientists have studied carbon-14 content in tree rings as much as 3,000 years old. It's difficult to go past that because we don't have any trees that are older than that. What the scientists discovered is that carbon-14 levels have varied as much as 70% over the last 3,000 years. So this means that while they were measuring the carbon in these tree rings, the C14 levels were different per ring, and as much sometimes as 70% in the same tree. Now, a lot of things could be responsible for that, but just as an example, volcanic explosions, an extreme heating event, or an extreme cooling event. The measurements correlated with certain events that occurred. The measurements of tree rings have been correlated with certain events that occurred on the surface of the sun. As a result, it's now known that carbon-14 in the atmosphere has not stayed constant. Therefore, the assumptions behind carbon-14 dating are basically incorrect. You can't assume that it was a certain amount of carbon-14 when the organism was alive, unless you were actually there to measure it. You cannot assume that it decayed at a regular rate over a period of years. In essence, assumptions for dating objects less than 3,000 years old are fairly accurate. This is particularly beneficial in the field of archaeology. Another assumption is made that the half-life of isotopes has always been the same. Consequently, radioactive dates are often found to be in conflict with each other or other dating techniques. There have been actual scientific experiments that have demonstrated that the half-life of isotopes can vary. So the scientific community as a whole tends to be unwilling to admit carbon-14 dating doesn't work for very old objects. When objects are given very old dates, like a rock that is 4 billion years old, this helps to back evolution. So scientists who want evolution to be true would negate their own theory if they acknowledge that the dates on many objects are incorrect. So, biblically, we believe in what the Bible tells us, and with the historical dating processes that have gone on, matching known dates with what the Bible says are the dates, with carbon-14 dating up to a certain limit. And it is believed that the Earth is fairly young, 6 through 10,000 years old. And science has actually proved that there are no philosophical problems with that, no observational problems with that, that no links are needed to any other information to make it true, and that the complex forms that were studied are universal, and the dating points to a young Earth. So the science actually backs up a young Earth. It just depends what the assumptions are when you start your scientific experiments. So that's it for Module 13. If you have any questions, be sure to contact me. If not, move on to your own problems, and we'll talk again soon when we begin our next unit.